Welcome back, llamas. We're skipping to block 7 on topic 9, probability, on page 287. The other blocks we're kind of able to skip because you don't need to know that as a 7th grader just yet. So the first thing, remember when we did this game a couple days ago and you had to bet on which number? You put the marbles in the slot, and that represented your bet of how often you thought that marble was going to be, or the dice was going to land on that sum. So we're going to use that thinking again. Who did we decide when we looked at the math, who should be rolled the most? 7 had the most sums possible. What were the sums that create a 7? 1 plus 6, 6 plus 1,
4 to 3,
4 and 3, 3 and 4, 2 and 5, 5 and 2. Okay, so there were 6 different ways. There were 6 different ways a 7 could be drawn, and then it started going down from there, kind of like a pyramid. So 6 and 8 had how many different ways? 5. 5 and 9 had 4. 4 and 10 had 3. 3 and 11 had 2, and then 2 and 12 only had one way of getting the sum. Okay, well, we're going to keep that fresh in our head for a second. Oh, I need to go back. So a new definition that we're learning today is called compound event. Well, what is a compound word?
2 things compacted.
2 words that smushed together that made one word. Like, give me an example of a compound word. That is a conjunction.
Backpack.
Backpack. You have backpack, 2 words, a backpack. That is a conjunction. Notebook. Note and book. Butterfly, butter and fly. Okay, I think we get the point. So, a compound event is where you have 2 or more things happening at the same time. This activity was a compound event. What was compound about it? How many objects did we use?
2.
2 what?
Dice.
It made it a compound event because I had 2 dice. If I rolled 1, that's not a compound event. Just one thing that's happening. Alright, so I have 2 dice on the board. Is that a compound event or just an event? Compound because there's 2 of them. And remember when we did that activity, I had all those math problems listed on the board of all the different ways the sum could be. Remember all the problems I had listed?
Yes.
Well, we're going to list them more in a chart form that's a little nicer and answer some questions about it. So, do you agree that the white dice could land on a 1, 2, 3, 4, 5, and 6? Is there any other possible way that could be landed on?
No.
The black dice can land on a 1, 2, 3, 4, 5, or 6. Any other way it could be landed on? No. So this is our total outcomes, our sample space. Doesn't really sound right, but how much, what's the word I'm looking for? How many events are in the sample space?
2.
There's only 2 things happen?
36.
36. There's 36 different outcomes in the sample space. Okay, and we were asked to find the sum of the dice. So the sum of the dice that lands on a 1 and a 1 is going to be a 2. So we're going to go through our chart and fill it in so that we can look at its data. And there is all the possible combinations of sums we could have gotten on that game. All right, so we should have our chart all filled in. Now we're able to answer some questions about this. And the first question we can ask on B, it says, what is the probability of rolling a sum of 12? Well, how many spaces or outcomes have a sum of 12?
1.
1 out of how many total?
36.
So, we need to write that in probability notation. There were a total of 36, and only 1 had a 12. So, they're doing a little extra math here down at the bottom. You don't have to worry about that. It's a little extreme. I just like that method. So, pretty easy. Can't be simplified. Part C says, what is the probability of rolling a sum of 5? So, how many spaces have 5?
4. 4.
1, 2, 3, 4. No more. So, the probability of 5, there's still a total of 36. 4 of them are 5. That simplifies to 1/9. Then they're doing a little more extreme math, which is good math, but nobody would really calculate it like that. So the probability of picking a sum of 5 would be 1/9. 2 says, what number or what sum is the most likely to happen?
7.
7, but why?
Because it has the most numbers.
Has the most numbers?
Spaces. Blank.
It has the most combinations. 7 is most likely because it has the most combinations of a sum of 7. Who would be next popular pick?
6.
6 or 8.
6 and 8 are tied. So they're equally likely to be the second most popular to pick. Okay, number 3 in your workbook is that game I just showed you. They wanted to see if you had a better chance of winning now that you have some probability knowledge. So I assign number 3 on your Agile Minds. You're just going to do the betting game again and see if your bets are better now that you have some math knowledge behind it. Number 4 is actually homework, but I thought we would do it together. And number 4 says that a teacher challenges the class to think about the probabilities of another game similar to the guess and win game. The guess and win game is the one with the marbles and rolling and doing the sum, the game I just showed you. You clear on that? So then a teacher says, I'm going to come up with a new game kind of like that game, but I'm going to call it evens and odds. And this time when I roll the dice, you're going to multiply and find the product of the two dice. And if you roll an even number, the teacher will get a point. And if you roll an odd number, the students will get a point. So we're going to look at how the game has changed. So we need to sketch a table. It was not very nice of them that they did not draw you a table. So we need to now look at the products of our table of landing on 1 through 6 on one dice and 1 through 6 on another dice. And product stands for,
The sum of two.
The sum of a multiplication.
it doesn't stand for sum,
The answer of a multiplication.
the answer of a multiplication problem. So that means I need to multiply these numbers. So these first list here is just my dice. So you might want to bold those lines. What is a 1 times a 1 then?
1,
1 times 2,
2,
1 times 3,
3,
1 times 4, 1 times 5, 1 times 6,
6,
1 times 2, 2 times 2, 2 times 3, 2 times 8, 2 times 4, 8. I think I'm just going to fill in here. 3, 6, 9, 12, 15, 18, 4, 8, 12, 16, 20, 24, 5, 10, 15, 20, 25, 30, 6, 12, 18, 24, 30, 36. Okay, so creating a chart of all the possible outcomes. So it's our sample space. So now we have our sample space. We're able to answer some questions about this game this teacher made. I kind of like this teacher.
She reminds me of
Yeah. She has a lot of Miss Adams tendencies. And she said, well, what is the theoretical probability of the product of 10? So if I'm looking for the product of 10, the probability of 10, how many products are 10? 2 out of how many total?
36.
36. Can that simplify?
Yes.
To
18.
1/18. So the probability of a product of 10 is 1/18. What word on my scale could I describe that as? Unlikely to happen. Okay. What is the theoretical probability of a 21?
Impossible.
Well,
Event.
because how many spots are 21?
0.
Out of how many total?
36.
Which gives me 0, which is impossible to happen. There is no way to get a product of 21, because 21 is a prime number. No, it's not. Just kidding. 7 can divide it. All right. D says, which 2 products are the most likely to occur? So 2 are tied for first, for the most happening. What 2 are tied for first?
12.
How many does 12 have? 12 has 4.
Unfair.
How many does 6 have?
It has more than
It has 4 as well.
4.
So they both are tied for first. So we can say the probability of 6, which is 4 out of 36, which is 1/9. Am that good then?
Yes.
Thank you. Then we had the probability of 12, had 4 chances out of 36. So it also has a probability of 1/9. Okay. Then E says, is this game fair? Let me direct you back to the number 4, that little paragraph. Says the teacher gets a point if they roll an even. The students get a point if they roll an odd. So look at your sample space. Let's see how many are actually odd. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 36 are odd. Who has the better advantage, the teacher or the student?
The children. The teacher. Oh, my bad.
He's back. The teacher used her brains and said, I'm going to win every game. And I get a point for every time you land on an even, and I'll let you have a point every time you land on an odd, and I'm going to win every time. So, is the game fair? No, because why?
There's more even than odd.
The teacher has a better chance because there are more even, maybe? Even numbers? Or products, really? And that is block 7. You have the rest of the time to work on online work. Thanks for listening. Have a great day. Like, subscribe, hit the notification bell. Buy Llama products. Peace out, home dog.
Bye.